Physical properties of elements of group 1. Before we start, let's see whether you still remember the elements of group 1 and their physical properties. Drag group 1 elements and drop them into the boxes provided and arrange them in ascending order of their atomic sizes and melting points. Good. You are right. Good. You are right. You are right. The elements of group 1 are arranged in their ascending order of reactivity. You can see that lithium is less reactive than sodium and francium has the highest reactivity. At the end of this lesson, students should be able to list the chemical properties of lithium, sodium and potassium, describe the similarities in chemical properties of lithium, sodium and potassium, relate the chemical properties of group 1 elements to their electron arrangements. Click on the blinking button to proceed.
There are 3 experiments that can be done to prove the reaction and reactivity of alkali metals. Since alkali metals are very reactive, let us first learn some safety precaution when handling alkali metals. Never touch alkali metals with your hand, especially when your hands are wet. Use a pair of forceps to take the metals. Only cut the metal when needed and cut it into very small pieces. This is because large quantity of metals can ignite and cause explosion.
Do not leave these metals exposed to air at any time. Always keep them in paraffin. Paraffin is a colorless, odorless and translucent liquid. Make sure that there are no inflammable organic materials near them as they can cause to fire. Click on the blinking button to proceed. Let us now do the first experiment to show reactivity of lithium, sodium and potassium with oxygen. Print the table provided to write your observation during the experiment.
Cut a very small piece of lithium with knife, then dry it with filter paper.
Use a pair of forceps to place the lithium on the scoop of the deflagrating spoon.
Then heat the scoop on Bunsen burner. When lithium begins to burn, plug it into a gas jar filled with oxygen. Now add 20 cubic centimeter of water into the gas jar. Then shake the mixture. Finally, add 2 to 3 drops of phenolphthalein solution in the mixture.
What can you conclude from the change of color of the solution? The solution becomes alkaline. When this experiment is repeated using sodium or potassium, similarly observations are obtained. Click on the blinking button to proceed.
Let's now find out the reaction and reactivity of lithium, sodium and potassium with chlorine. Print the table to write in your observation. Cut a very small piece of lithium with knife, then dry it with filter paper.
Use a pair of forceps to place the lithium on the scoop of the deflagrating spoon.
Then, heat the scoop on Bunsen burner. When lithium begins to burn, plug it into a gas jar filled with chlorine. Write down your observation in the table.
Click on the blinking button to proceed.
Let's now find out the reaction and reactivity of lithium, sodium and potassium with water. Print the table to write in your result.
Use a pair of forceps to take lithium and then drop lithium metal into a bowl of water. Take a piece of red litmus paper and dip it into the water.
Write what happens to the red litmus paper in the table. Now, use a pair of forceps to drop sodium into the bowl of water.
Take a piece of red litmus paper and dip it into the water.
Write your observation in the table. Finally, use a pair of forceps to drop potassium into the bowl of water.
Take a piece of red litmus paper and dip it into the water.
Write down your observation in the table.
Click on the blinking button to proceed.
How quickly the metals move on water also shows reactivity of the metals. Therefore, the reactivity order of these metals is lithium, sodium, and then potassium. Meanwhile, lithium, sodium, and potassium turn red litmus paper into blue. This indicates that lithium, sodium, and potassium produce an alkali solution.
Click on the answer button to know the equations of the experiment.
Based on the results, we can conclude that the reactivity of alkali metals with water increases from lithium down the group.
Click on the blinking button to proceed.
Group 1 elements. If we look at the arrangement of electron for these elements, we can see that all alkali metals have one valence electron. Therefore, elements of group 1 have similar chemical properties. This means they exhibit the same chemical reactions. Even though they have similar chemical reaction, their reactivity increases as we go down the group.
If we draw the electron arrangement for each element, we can see that these elements have one electron in their outermost shell. Lithium, for example, has a proton number of 3. Therefore, it will have 2 electrons at its inner shell and 1 electron at its outer shell.
During a chemical reaction, lithium donates this electron to attain the noble gas stability. A cation, positive ion, with a charge of +1 is formed.
Same thing goes with sodium. Sodium with a proton number of 11 will also have one electron at its outer shell. During a chemical reaction, sodium donates this electron to attain the noble gas stability. A cation, a positive ion with a charge of +1, is formed.
The relation between reactivity of group 1 elements and its electron arrangement is its group 1 element's reactivity increases from lithium to francium because as we go down the group, the elements become more inclined to react and release their valence electrons.
Click on the blinking button to proceed.